Hello dear students. Today we are going to discuss about the numerical problem of multiplate clutch. This is the simple numerical problem related to the multiplate clutch. Here you can see that the multiplate clutch has 5 plates having 4 pairs of active friction surfaces. If the intensity of pressure is not to exceed 0.127 Newton per mm square, find the power transmitted at 500 rpm. The outer and inner radii of friction surfaces are 125 mm and 75 mm respectively. Assume uniform wear and take coefficient of friction is 0.3. So this is the numerical problem. So we have to solve this numerical problem systematically. So now the given data is, this is the given data. Here you can see n1 plus n2 that is equals to 5 is given in the question, and n is equals to n1 plus n2 minus 1. You know already that in the previous we have already discussed in previous lecture. N is equals to n1 plus n2 minus 1, that is equals to 4, and r1 and r2 inner and outer radius, and intensity of pressure Pmax is equals to 0.127 Newton per mm square, and coefficient of friction is equals to 0.3, and n is equals to 500 rpm. And also given is the uniform wear theory. So we have to consider the uniform wear theory when we are solving this numerical problem, and we have to find out the value of power transmitted by the clutch. So initially, we should know, or we know that the power transmitted by the clutch, P is equals to 2 pi nt upon 60. Here you can see that this is the torque transmitted by the clutch. N is given, that is 500 rpm, and if we can calculate the value of torque transmitted by the clutch, then we will have the value of power transmitted by the clutch. So the torque transmitted by the clutch T is equals to N mu WR. Here you can see the value of the N is equals to 4. It is given in the given data, and mu is equals to 0.3. Now we have to calculate the W. W, that means axial load transmitted to the clutch. So this is the W. W is equals to 2 pi C R1 minus R2. So now we have the value of R1 and R2, but we don't know about the C. That is a constant. So we have to calculate the value. First of all, we have to calculate the value of C also, so that we can easily calculate the value of W. So value of C, that means C is equals to P max into R2. That means maximum pressure into minimum radius. That here you can see that in case of the uniform wear theory, maximum pressure at inner radius and minimum pressure at outer radius. So we get the value of C from here, because P maximum pressure is already given in the question, 0.127, and R2 is equals to 75 mm. So now we have to substitute the value of C in this equation. So this is by which we can calculate the value of W. Now substitute the value of W in the torque transmitted by the clutch. Now we have to calculate the value of capital R. This is the mean radius. Mean radius in case of uniform wear theory, the mean value of the mean radius, that is equals to R1 plus R2 divided by 2. So we have the value of R1 and R2, so that easily we can calculate the value of capital R and substitute the value of capital R in the equation torque transmitted by the clutch. And now we have the value of torque transmitted by the clutch. So this value of T, we have to substitute this value of T in the equation power transmitted by the clutch, P is equals to 2 pi nt upon 60, so that we can calculate the value of power with the help of this formula. The value of the power is 18.8 kilowatt. So you can calculate easily the power transmitted by the clutch with the help of this procedure. I have already explained all the formulae used in this numerical problem. So now value of the P is equals to 18.8 kilowatt. Thank you. Thank you very much.